During a chemical reaction, matter is not created nor destroyed. Atoms move to generally more favorable arrangements and form different chemicals, but atoms are not formed or destroyed. The law of conservation of mass is a summary of that observation, and the total mass of chemicals before a reaction is equal to the total mass of chemicals after the reaction. This law applies to both chemical and physical reactions. Chemical equations that obey the law of conservation of mass are known as balanced, and balanced chemical equations are generally the most useful form of an equation. A chemical equation is balanced when it has the same number of each type of atom on both sides of the arrow. When we consider a chemical equation, it is important to distinguish between the coefficients and the subscripts. Coefficients are numbers in front of a chemical formula and signify how many molecules there are, while subscripts are the small numbers to the right of an elemental symbol and are part of a chemical formula. The number 1 is not expressly written for either the coefficient or a subscript, but when balancing a chemical equation, we can only change the coefficients or number of molecules. Never ever do we change the subscript of a formula. Let's look at how to count atoms in a chemical formula or chemical equation. To do that, we multiply the coefficient by the subscript for each element. I've placed lines in front of each chemical formula to remind us that we can only change the coefficient when we balance a chemical equation. Since there's no number on the line, the coefficient for each chemical is currently 1. Let's look at carbon. On the left of the arrow there is 1 times 1 or 1 carbon, and on the right of the arrow there's 1 times 1 or 1 carbon atom. Carbon is balanced. Next, let's consider hydrogen. On the left, 1 times 4 is 4, and on the right, 1 times 2 is 2. Hydrogen is not balanced. For oxygen on the left, 1 times 2 is 2, while on the right of the arrow, oxygen is in both molecules, so we add to get our total number of oxygen atoms. From carbon dioxide, 1 times 2, which is 2, and from water, 1 times 1, which is 1, and 2 plus 1 is a total of 3 of oxygen atoms on the product side. To get this balance, we'll change the coefficients. I'll leave oxygen for last. Since it's an element on the reactant side, I can change its coefficient to anything once everything is balanced on the right-hand side. To balance hydrogen, I place a coefficient of 2 in front of the chemical formula for water. 2 times 2 is 4, and now my hydrogen is balanced. I have 4 hydrogen atoms on both sides. However, this coefficient of 2 changed the number of oxygen atoms from water. I now have 2 times 1 or 2 oxygen atoms from water. So 2 from carbon dioxide, 2 from water. I have a total of 4 oxygen atoms on my product side. To balance the oxygen atoms, I'll place a coefficient of 2 in front of the chemical formula for oxygen on the reactant side. Now I have 2 times 2 or 4 oxygen atoms on the reactant side and 4 on the product side. I now have the same number of carbon atoms, hydrogen atoms, and oxygen atoms on both sides of the arrow. The equation is balanced. If you have never balanced a chemical equation before, you will find extra practice in the form of a worksheet, as well as links to interactive practice in Canvas. Like any concept based on math, balancing chemical equations takes practice.